Okay, write down in Young's double slit experiment that is performed using sodium light of wavelength 589.3 nanometer, the interference pattern is observed on a screen 100 centimeter away. So what is 100 centimeter? Capital D. So capital D is 100 centimeter or 1 meters. What is given is the 10th bright fringe. 10th bright fringe has its center at a distance of 12 centimeter from central bright. Okay? Find out separation between the slit. Small d is what?
48 and 10 combined.
No, all wrong.
So 490.3 into 10 combined.
Oh, sorry, this is 12 mm. As if you got it, huh? Show me. Okay, good. So,
490.3 10 combined 6.
Yes. Okay, so the thing is, 10th bright fringe location is what? 10 lambda d by d. That is equal to 12 mm. So from there you get a small d. It's like 5 or 6 lunch box. One at 10 a.m., then at 12.
Actually, sir, one is for 10 o'clock, one is for 12.
It will be written on the lunch boxes. See, better, this you eat at 10 a.m. And this you eat during the CENTUM class. When sir is teaching Young's double slit experiment, just write on the lunch boxes, Young's double slit experiment, lunch. Okay. Next question. See, try doing it properly. I mean, you may not be able to get everything sitting here itself. But make sure when you go back home, master this topic, because this topic, the depth is not much. I mean, whatever varieties we discuss now, that's it. If you solve 60-70 problems your own, you're done with this topic. And ray optics also similarly. Fine. You are assured to get marks in this chapter. 100% assurance in advance also. Do not miss on that. Okay. Finish this chapter in next 2-3 days. I mean, not the entire chapter because I am also not done with it. But whatever we have discussed, we have done a good chunk of this chapter. We have discussed around 80% of the chapter is done. Make sure you finish HC Verma at least before coming next class. Anyways, coming back to the question. The beam of light contains two wavelengths. Lambda 1, 6,500 angstrom. Lambda 2, 5,200 angstrom. Two wavelengths are there. To obtain interference fringes in a Young's double slit experiment, the distance between the slit is 2 mm. Distance between the plane of the slit and the screen is 120 centimeter. These things are given. Okay. You need to find this. Part A. Distance of third bright fringe. Third bright for lambda 1. This is how much? First do this, then we'll go to next part. Quickly.
So Armstrong's 10 to the minus 10.
Yeah.
10 to the minus 10? 10 to the minus 10? Huh?
Armstrong is 10 to the minus 10.
Armstrong. Sir, what my answer?
Oh, Van Armstrong is it? Your answer is it?
Yes, the answer is 170 to 10 to the power minus 5.
Yeah. Okay. Did you get Samuel?
So 117 and 10 power minus 5.
Huh. Coincide with bright fringe of lambda 2. Have you understood what is asked? B part. What?
Yes, okay.
Should I?
So, sir.
Those who are watching the video, you can also feel as if the class is going on and you can try this. Don't watch it like a movie. Alright? No. Sorry. Now should I do it? I will start out doing something related to this question. I use you to be sick terribly. What about it?
You are silence.
And you're sitting next to him. Huh? You like bacteria and viruses.
Old school.
Huh?
Old school. Yeah, 65 and 65 is 52 is the enormous value. When the ratio. So we do it. 60 number for n1
Okay.
is 60.
Now I will do this question. Fine. Acha. See, the location of maxima is what? N lambda d by d. Now this is suppose for lambda 1. For this is y1 and y2 is suppose will be n times lambda 2 by d. Are you getting this? See, this integer and this integer need not be same. Fine. So n lambda 1 d by d will be equal to m lambda 2 d by d. So I can say n by m is lambda 2 by lambda 1. What is lambda 2?
So 6000.
5200. Lambda 1 6500 angstrom. So this is gone. 13 4s of this, 13 5 of this. So this is 4 by 5. Now what is the minimum value of n and m for which it is 52 by 65? Given n and m has to be integers. N is equal to 4 and m is equal to 5. There is a minimum integer. Fine. For minimum y, I need to find minimum integer for this ratio. Getting it? So n is 4 and m is 5. So put n is equal to 4 over here. 4 lambda 1 6500 divided by small d. Alright, capital D on here. 1.2 divided by 2 mm. 2 into 10 to minus 3. Why are you not getting this? What do you get?
So I didn't simplify. N1 by N2 is equal to 65 by 2. I didn't simplify it 4 by 5. I just took 65 and used it.
So you did know it is multiple of 13?
So I didn't do it.
Okay. Take it. No problem. Where is duster? Newspaper works so well. Use newspaper only. Bring newspaper, okay? Next class onwards.
So we get it score.
Don't put it on record. Gets recorded. Okay. Anyways, the last question for the day. Fine. So you have the Young's double slit experiment like this. From here, intensity I0 and I0 comes in very simple experiment. I mean, there is no complication as such. Here, what will be the intensity? Center. Intensity formula is what? 4 I0 cos square 5 by 2. What is 5 over here? What is the path difference over here? 0. So this is 4 I0. This is 4 I0. Okay. Find the location where intensity is 2 I0. What is this y where intensity is 2 I0? Do it. Everything else is given, like t is given, this is capital D, lambda, whatever you need, just assume it. You got something?
Yes. So pi is equal to pi by 2.
Okay, let's see. First of all, when intensity becomes 2 I0, I can get the phase 4 I0 cos square 5 by 2. So 2 and 2 gone. Sorry, this is 2. I0 gone. So cos square 5 by 2 becomes 1 by 2. So cos 5 by 2 becomes 1 by root 2 plus minus. So plus minus means one point will be above, one point will be below. So I just take plus over here, just for the sake of simplicity. 5 by 2 will be what? 5 by 4. So 5 will be pi by 2. So basically I need to find out location where phase difference is pi by 2. Okay. At the location y, what is the path difference? D tan theta. It happens to be dy by d. So this is a path difference at a distance y. Fine. So what is the phase difference corresponding to this? Lambda corresponds to 2 pi. So dy by d correspond to 2 pi by lambda into y d by capital D. So this should be equal to that. Are you getting my point? Okay. So when you equate it, what do you get? 2 pi by lambda y d by d is equal to pi by 2. Pi and pi gone. So y is equal to d lambda by 4d. So at this location, above and below, you have intensity which is half of the maximum possible intensity. Okay. So today we have covered almost 80% of wave optics. Fine. And almost 90% of numericals will be on whatever we have learned today itself. Fine. Go back home. Today itself, at least try 30 questions your own. 30 questions will take 1 hour. Remember this. Have this thing in your head. 30 questions is equivalent to 1 hour of effort. Don't count your effort on how much time you are sitting on the desk. Count with number of questions. 30 questions means 1 hour. Whether you do it in 5 hours, 6 hours, whether if you put phone in front of you, 30 questions will be done in 5 hours. Fine? So I am asking you to spend 1 hour only and solve 30 questions. Okay? And next day, tomorrow, we don't have CENTUM, so at least try 100 questions. Then this chapter will be done for all. You will never have to look back on this chapter. Okay? That's it. That I will put it. You guys, if you want, you can come one by one and tell. Your attendance will be recorded. Your attendance will be recorded for like entire day.
Take a recording.
You can come here. I am present. I am so and so.
Okay,
Come. Whatever.
I'm Samuel, I'm present.
That's it. Why you like CENTUM and all that you have to say.
Oh,
I'm Siddhant. Today is the 4th of July 2018 and we have physics today. We had a very nice class on wave optics.
He is not as innocent as he looks, okay? Who else? Are you going again?
I love CENTUM. It's the greatest coaching class
Acha.
in the universe.